Hi dear students, welcome to PMSH classes. This is the lecture 2 of motion in a straight line, and the topic that we are going to discuss are scalar and vector quantity, distance and displacement. This video will be useful for students who are going to attend board examination like CBSE board examination, Kerala state board examination, as well as for students who are focusing on competitive examinations like KEAM, KVPY, NEET, JEE, etc. And let us see what is a scalar and vector quantity. Okay, you may please take a pen and paper and take down the notes. So first of all, we will discuss what is a scalar quantity. Okay, what is a scalar quantity? Scalar quantity means that physical quantity is only concerned about magnitude. In that we does not consider the direction. Okay. For example, time is a scalar quantity. We usually does not say to which direction. Right? We only say the magnitude. Such quantity like temperature, current, distance, speed. Some are the examples for scalar quantity. So you can write that the physical quantity, the physical quantity which have only magnitude is called scalar quantity. Is called scalar quantity. Some of the examples are speed, distance, then time, temperature, then current, work, energy, power, etc. Okay. So what is the specialty? In a scalar quantity, we are only concerned about the magnitude. We does not consider the direction of that quantity. Okay. And next, what is a vector quantity? Vector quantity. Yes, as you have thought, in these physical quantities, we consider magnitude as well as direction. We will specify to which direction. For example, 5 kilometer per hour to north. Okay, if we are saying 5 kilometer per hour to north, 5 kilometer per hour is the magnitude of the velocity. And to north, that north is the direction. So when we say a vector quantity, we not only say the magnitude, but also the direction. Okay. So you can say that the physical quantity, the physical quantity which have both magnitude and and direction. Okay, is called vector quantity. Clear? And some of the examples, we can say velocity. Okay, velocity. Then we can say displacement. then acceleration, then torque, etc. Okay, so these are some of the examples for a vector quantity. So I think it is clear what is a scalar quantity and vector quantity. In scalar quantity, we are only concerned about the magnitude, and in vector quantity, we are concerned about magnitude as well as the direction. Okay, so how to deal with vectors? Okay, usually when we deal with vector quantities, we have a mathematics branch called vector algebra. Vector algebra means we are discussing about the addition, subtraction, multiplication of the vectors. Okay, it is concerned about the vectors. But when you do some problems in this chapter, that is motion in a straight line, okay, you will learn some of the parts of this vector algebra in motion in a plane, that is the next chapter. But when we are learning here in motion in a straight line, we usually use sign convention for vector quantities. For scalar quantity, we don't have to apply sign convention. We can just add, subtract, multiply, divide as we have learned in the normal mathematics. Okay. But when we are dealing with the vector quantity, we use sign convention. And this sign convention is basically two types. Okay. First, I will discuss the most useful and generalized one, that is a Cartesian sign convention. Okay. So this is the first way of using the sign convention. There can be some sort of spelling mistakes. I have already told you. You have to clear that. Okay. I'm not concerned about the spelling. I'm just concerned about the concepts of physics. Okay. So I'll be focusing on that. So we'll say Cartesian sign convention. It is similar to what you have learned in the plane. Okay. You have learned XY plane, right? This is how we represent an XY plane. This will be our origin. Okay, you know that all. But we are seeing the sign convention for vectors. Usually we know we consider this direction as positive x-axis, right? And this direction as negative x-axis. This we consider as positive y-axis. And this direction we consider as negative y-axis. Isn't it? So what we are doing is, we when a physical quantity is to the right, okay, when the physical quantity is to the right direction, we put that as positive. Okay, so when the physical quantity is to the right, we take it as positive. When the physical quantity is in the upward direction, that also will be taken as positive because it is the positive y-axis, right? So we consider that as positive. When the physical quantity direction is to the left, left means this direction, that will be taken as negative. Okay, and if it is to the downward direction, then that also taken as negative. Clear? And I hope all of you know how we consider north, south, west, east. Okay, this I hope you already know that. I'll just draw once again for you. Okay, how do we consider? This is north direction, this is south, this is west, and this is east. Okay, so in a problem, okay, I'll tell you an example. In a problem, if they tell a body having velocity 5 kilometer per hour in the north direction. North direction is positive y direction. So that according to the Cartesian sign convention, you have to take that velocity as positive plus 5. Okay, plus 5 kilometer per hour. If they tell you a body have velocity 5 kilometer per hour in the south direction. Okay, south is the negative y-axis direction. So you have to take minus 5 kilometer per hour. That is how you apply sign convention to deal with vector quantities. Okay, and now this was the first method. Okay, this was our first method of sign convention. And usually it is more generalized one. It is convenient to use this first method. In some cases, if you need, you can use the second method. Okay, what is it? Here, it is second method is convenient for a problem involving one or two bodies. Okay, a problem involving one or two bodies. When there are more than two bodies, it is very good to consider the first method. Okay, so in the second method, to the direction in which the body is traveling, to the direction in which the body is traveling will be taken as positive, and opposite to that direction will be taken as negative. Okay, you can say the direction to which the body is traveling is positive, and opposite to that is negative. Clear? Okay, simply if I'll draw you a figure just to explain this. For someone, for some students, it may not be clear. So I'll tell you that. Suppose if a body is moving to the left, okay, a body is moving to the left, then you take the left direction as positive because it is the direction in which it is moving. So all the physical quantity to the left will be taken as positive, and every physical quantity opposite to this direction, that means to the right, will be taken as negative. That is what it is all about. Okay, so this is useful for problems involving one or two bodies. When there are more than two bodies, you go for the generalized method, Cartesian sign convention. Okay, now we will go to the next topic. That is, we are going to discuss distance and displacement. Okay, so we know that distance is a scalar and displacement is a vector quantity. Okay, so now we are going to clearly understand what is distance and what is displacement. I'll tell you. Suppose a body starts from point A and it is traveling to point B. Okay, and let us say that the body have traveled like this. Clear? Then the total path length, that is, the total path length will be this path, right? This path. The total path length is called as distance. Okay, that total path length is called as distance. This total path length will be called as distance traveled by the body. Okay, and you know it, A was the initial position, right? A was the initial position, that is the starting point. Okay, initial position, or you can say starting point. B is the final position, B is the final position, or you can say the ending point, right? Ending point. Then the displacement is the shortest distance between initial and final position. Displacement is the shortest distance between, okay, the shortest length between initial position and final position. How can you find the shortest? How can you find the shortest length or shortest distance? Yes, it will be the straight line distance, right? It will be the straight line distance. So this will be our displacement. This will be our displacement. Okay, you can draw this figure to understand what is distance and displacement. Okay, so the total path length covered is distance And displacement means it is the shortest distance between initial and final position or starting and ending point. Clear? Yes. Now we will discuss some of the difference between distance and displacement. Okay, we will discuss both similarities as well as both the dissimilarities. Okay, similarity and dissimilarity. So here is a distance. Let us make a box. Or okay, here is displacement. There are two columns. Okay, so what is distance? Distance, it is the total path, right? It is the total path covered by a body. It is the total path covered by a body. Whereas displacement, it is the shortest distance between initial and final position. Okay, it is the shortest distance between initial and final position. Okay, and we know distance is an example for scalar quantity, right? We does not specify the direction, we only tell about the magnitude, therefore it is a scalar quantity. Whereas displacement is a vector quantity. Clear? Then the distance can be 0, right? 0 means the body does not change the position. It is just at rest, right? So it can be 0. Distance can be 0. It can be 0 or it can be a positive value, right? It can be a positive value. Whereas displacement, it can be negative because we have already learned the sign convention for vector quantity, right? We know displacement is a vector quantity, and when the body is traveling to the left or when the body is moving downward, as per the Cartesian sign convention, it will be considered it is considered as negative, right? So it can be negative. Displacement can be negative. It can be 0 or it can be positive. Okay, clear. Now what is the SI unit? What is the unit? SI unit? SI unit is meter. There are many other units like kilometer, centimeter, etc. But the SI unit is meter. Here also the SI unit is meter. Clear? Meter. So we told that the displacement can be negative, 0 or positive. And distance can be 0 or positive. Right. So the displacement can take negative values. That means displacement will be displacement will be less than or equal to distance. Isn't it? I hope it is clear. Displacement will be less than or equal to distance because displacement can be a negative value. Okay. Whereas distance cannot be negative. So we can say displacement will be less than or equal to distance. When will be it equal? When will displacement will be equal to distance? Yes, when it is traveling in a straight line. If it is traveling in a straight line, then both displacement and distance can be equal, right? So this is very important. Okay, you have to note this. Displacement is less than or equal to distance. Clear? Now, for the better understanding of this concept of distance and displacement, we have a problem. So let us see how to solve this. The question is, an athlete complete one round of a circular track of diameter 200 meter in 40 seconds. Okay. So there is a circular track. There is a circular track. There is a circular track. And the diameter for this circular track is given in the question as 200 meter. And the time taken is 40 seconds to complete one round. Okay. Now what is the rest? What will be the distance covered and displacement at the end of 2 minutes 20 seconds? Okay. So in physics, whenever a question is given to you, you must first analyze the question very well. Okay. The analysis of the question means you have to understand the data given and also to which part of the theory it is connected. It is connected to distance and displacement, right? So that is what analysis of the question. After analysis, you have to write the given data. Okay, you can write the given data. Then you can draw figure. If possible, you can draw some figures to represent the situation of the question. And you can write the equations of the physical quantity discussed in the question so that it will be very simple. So what I have drawn a figure, a circular track, and the diameter is given to be 200 meter and the time is 40 seconds. We need to know what is the distance and what is the displacement at the end of 2 minutes 20 seconds. Okay. So given time is at the end of 2 minutes 20 seconds. 2 minutes 20 seconds. 2 minutes 20 seconds means, okay, let this be for one round, right? Let be T1, let be T2. Okay. 2 minutes 20 seconds means we have to convert it into SI. SI is seconds. Okay, time SI unit is second. So 2 times 60. How to convert minute into second? You have to multiply with 60 plus 20. So that is 120 plus 20. That is 140 seconds. Okay. So the time given 140 seconds. In 140 seconds, what will be the distance and what will be the displacement? So you think like this. For one round, it takes 40 seconds. Then within 120 seconds, how many round will be there? Okay. So number of round. How to find number of round? Number of round will be 140 by 40. That is, you can cancel 0, 14 by 4, 7 by 2, 3.5 round. Clear? So by this time 140 second, this athlete can complete 3.5 round because for a single round it is 40 seconds and the total time is 140 seconds. So you can divide the total time by time for one round. So you get 3.5 round. Now you are asked to find the distance. You are asked to find the distance. If it complete one round means it is the circumference of the circle, isn't it? What is the equation to find the circumference of circle? Circumference of circle? Yes, 2 pi r, right? 2 pi r. For a single round, he will take a distance 2 pi r. Here there are 3.5 round, 3.5 round. So total distance is nothing but 3.5 into 2 pi r. Clear? So that is going to be 7 pi r. Okay. R is given in the question. They have given the diameter. Diameter is 200 meter. Diameter is 200 meter. So what will be the radius? This will be the radius R. That will be 100 meter. Clear? So you can say that 7 into pi is 22 by 7. Radius is 100. So you cancel this 2. So it is 2200 meter. That is the distance covered. Now you have to find what is the displacement, right? So we know that distance is the total path length, whereas displacement is the shortest distance between initial and final position. So we need to know what is the initial position and what is the final position for this athlete. So suppose if the athlete starts from here, it is the initial position. The athlete is completing 3.5 round. When one round is completed, he reaches the position where he started, that is I. When second round is completed, he is at I itself. When the third round is completed, he is at his initial position. Then there is a zero point 0.5 round. He will be at this position. Clear? 3.5 round. When 3.5 round is completed, initial final position will be this F. Clear? So what is the shortest distance between initial and final position? Yes, as you can see in the figure, it is the diameter of this circular track. Okay, so you can say displacement is equal to diameter of circular track, and which is equal to 200 meter. Okay, so this is how you solve questions based on distance and displacement. When you are asked to find the displacement, you have to know where is the initial position and where is the final position. Okay, so in the next lecture, we will be discussing the concepts like speed and velocity, and also average speed and average velocity. So see you in the next lecture.